Welcome, everyone. Thank you for having me. I'm Yeray Cabello. I'm a father of 4 little kids and husband. I'm also a consultant. I work in partnership. My company is consistently eventful. I work in partnership with AT Data. And since this is a platform engineering meetup, I'm not going to try to convince you about doing platform engineering, obviously. But I'm going to convince you on doing event sourcing, which is, you know the kind of people. I'm one of them, this kind of people that never stops talking about event sourcing. The thing is, event sourcing comes with its own technical challenges that are tough. And you can work around them, or you can make them easier for you if you apply the same principles that we apply to platform engineering. You know, eventual consistency, all of these little issues. Right. Eventually RESTful is just a wordplay with eventual consistency in event sourcing. Word of warning, it's not actually a REST API that you're going to have. It's what most people call a REST API, which is an open API spec that you can just have points over it. So we're just going to go over 3 things. First of all, what is event modeling, which is a special flavor of event sourcing, why you should do it. What is consistent API, how it makes it easy, how it makes it natural to use event sourcing. And finally, I'm going to do a small demo. There we go. So the major reason for this, and the argument that I tend to make, is a historical one, and literally historical. The history of humanity begins when we write the first document. We consider that history started back then. And the oldest document that we have translated so far is a list of kings and dates, which is double history, because it's the beginning of history, and history is pretty much kings and dates, as an historian. Thing is, we tend to think on information systems like this. Historically, when we made a warehouse, when we did an accounting, for example, which doesn't sound particularly exciting, but we develop accounting across many cultures, and they are pretty much the same. We end up unifying them for international markets, but they develop differently. They develop separately and in a very, very similar way. It's just the way we are wired to think about businesses. And this is the story. When you're working with a stateful system, when you're working with records and updating, when you have a problem, you need to figure out how you got here based on the state that you have right now. That's pretty much forensics, right? When you need to figure out where you are and you have the whole history of how you got here, that's accounting. And that's significantly easier. There's a reason why we make shows about CSI and we don't make shows about accountants, except that movie, which is pretty good. So why aren't we developing applications like this? If this is the natural way we think about businesses, and by the way, this is for line of business application. Are you familiar with the term, line of business? Yeah? Cool. Right, this applies specifically for line of business application. If you try to develop something like Photoshop or the streaming services of Netflix using this, you're probably going to be hanging yourself in technical terms. The reason we don't do event sourcing, it's pretty much because storage used to be horribly expensive. Well, we had Moore's law. We had processors that were significantly faster. We had significantly more memory accessible. So we sacrificed storage space because we had the performance to handle that. And we created these systems that are stateful. Okay? What's the issue with this? When you start developing a relatively simple business model, you have a warehouse and you have to retrieve stock. So if you want to retrieve stock, if you're doing the classical DDD or CQRS system, thank you, you have your stock aggregate, which has some policies. In this case, is probably do not retrieve more stock than you have. You issue a command, you hit the endpoint, you check whether you have the policies, you fetch that from the database, and then you put something in a message queue because you have an alert system to tell people that a product is running low. And then you have, if you have separate queries from their separate write and read models, if you're doing CQRS, you also have to update this. What you end up having is that once you start introducing more and more rules, so this is a warehouse, okay? Why do you take stock out of a warehouse? Because you're making an order, but you're making an order of several products. And maybe those products are being served for different warehouses. And then you start coordinating all of these little things. And you start doing things like, we have to pre-reserve the stock. Once we know that all of the pieces of stock are pre-reserved, you have to confirm the reservation, then you complete the order, then you can create the payment, and so, and so, and so. So what happens is that in order to solve those issues, there are eventuals. There are things that are happening in your system that you're not just records being updated. Right? If you don't work like that, then you end up having your message queues serving something. So you end up having a saga, and you end up defining that you reserve the stock, you create the order, you confirm the reservations, you do all of these little things, then you cancel, you need to update, you go back and forth, you start drawing tentacles, and before you know, you end up with a proper, surprise! Gotcha. Yeah.
This is the most interactive presentation ever.
Yeah. Obviously, because you want to decouple your code, the code that has a business logic from that, you end up making your ports, okay, and then you end up putting there your adapters, right? And you end up fancy hexagonal architecture, and then you get that big model right there in the middle with the ports and adapters around. You light it up. That's how consultancies are born, by the way. Okay.
Hey.
Yeah. I'm a consultant too, so yeah. I know. Come on. So the thing is, you end up doing a lot of things separately because the architecture is part, in the end, of what you're designing. Well, when you're doing line of business systems, what happens is that most of the time, you just have a simple story that goes from left to right. And the architecture for systems like this is exactly the same, whatever the feature you're developing. And that's one of the reasons I like event modeling as a way to design systems if you apply a platform approach to it, okay? This is the same thing. You're going to retrieve a stock. Let's say that this is just a screen for the warehouse clerk at this moment. So you just issue the command, you emit this event. If you're low on stock, you also emit an event saying, hey, send an alert that the stock's low. And as part of the framework, the read model, which is the equivalent of the query in CQRS, gets updated automatically as a consequence of this. So when it comes to writing code, the blocks that you write is this little integration to send the email, a function that maps. So you have the aggregate that you will have in DDD. It's represented by this swim lane. So you have just a function that projects from this swim lane to this. You have a function that makes a decision when you're trying to issue the command. You have a function that determines whether you should project this event or not. And you have a function that just calls the integration. Everything else is handled by the framework. By the way, this is not a sales pitch of my framework, which is free and open source. There's other technologies that do this. Axon IQ, the Critter stack. There are a few stacks out there that do this. Okay, this is the way we do it because we're heavily opinionated on doing these things. And the story is, this is something that you can hold in memory because it's a story. And we are made to remember stories. It's the way we have transmitted information before we wrote things. Matter of fact, if you have seen The Mentalist or read Sherlock Holmes, you have heard about the Mind Palace. When you see one of these memory competitions, they're fooling you. It's an attention competition because you just have to pay attention and make a story with the numbers, and then you have to remember the numbers. And that's how they do these kind of things. This is why this works, because you can reason about this, because the architecture doesn't get in the way. I repeat again because I have to repeat this a few times. This is exclusively for line of business development, okay? Because normally things that are line of, the example that I gave at the beginning, that we think that way. And we have been building information systems before computers as event logs. So normally what tends to happen is that the way business thinks about business is this way, left to right. So these models are usually way more likely to accommodate changes than a model that is stateful. Because you have to translate history into state, then design your architecture. And when the change comes, what is happening inside of the mind of the product people is a change to the history, not a change to the state. Now you do not only need to translate this model that is stateful, you also need to translate the change. And database migrations, I don't know about you, but I have a screw up one or two. Right? So, consistent API. One little thing that I forgot to mention. This is something that we call a slice, right? And when we have the list of stock, this is something that we call a slice. Bear that in mind. And an integration is also slice. Keep that term in the back of your mind. Consistent API, what is it? So the command that you saw there will be represented just by a single class, which is, well, by a single class that consumes the entity. So you define some logic to make a decision whether you should retrieve the stock or not. In this case, where you're going to go with, we have enough stock. Right? Everything else is handled by the framework. You define in an abstraction, well, you require this role to issue this command, and this belongs to this business domain. And the framework takes care of generating the endpoints, wiring all of the validation. If you attach files to it, it will recognize them and attach them to the entity, and it will store the events on the database. So you have a function that doesn't have any dependencies handling this case. Same thing happens with the integrations. So in this case, if we retrieve the stock and we're low on stock, we will emit an event to send an email, and that there is something listening to these events. And when these events happen, and it's time to issue, because you can delay, you can add conditions on the execution of on something, the email will be sent. And we also got the read models, which again is just a function. You take the aggregate and you convert to that. The system takes care of creating the tables, creating the relationships, indexes, and if you were to modify a model, it will just create a new table and read the whole history of the system. No data migrations. Bear that in mind. Never again. So demo time. Let's see how can I handle a MacBook. I'm just going to show you the model. So this object, this event model object, is the thing that you pass to the framework. This is the object that you pass to the framework. And the framework will then generate the endpoints, generate the tables in the database to project, filtering, sorting, you name it. So in this case, we have the stock, and we have a command to receive stock, one to retrieve. We have two read models, one that has all the stock of our products, another one that has only the products that have low stock. And we could show them. So you can pre-filter, not querying, but just have only the data that you want, and you can have different access levels to these models. Then you can have that in a dashboard or something like that. And then we have the low stock email projection. I'm not going to show the email because we're going to go over time. But this contains the logic that determines whether you should send the email or not. And I will just show you. So this is the stock entity that has just the product ID and the quantity to simplify. And what it does is it starts in a default state with the product and no amount. And every time there's an event receiving stock, it projects a copy of itself with the amount increase. It's all immutable to prevent race conditions and all that. So this is the core where everything derives from. Then we have a command. I'm going to go to retrieve because it's the one that has a little bit of meat on it. So this is, you just define the signature, the thing of the command. You give it an area tag, so it's group in the API definition. You give it a description because it generates the documentation. And the authentication, in this case, it requires this role. If I were to put more roles in the constructor, it would require all of them. And then the decider, and the decider says, require that the entity is there. So this, you don't have to return a 404. If it's not there, it's already handled by the framework. You just handle the cases that are specific for your business logic, which is if the quantity is greater or equal to the quantity in the command, you can emit an event that is stock was retrieved, and if not, we get a conflict. And the way, there's also validation here, just to show this is all wired up by the framework. You don't need to add any of this. And then we have a read model that has the product ID and the quantity. How does this look like? I think this is the browser. Yes, all right. So you can see these are most of these endpoints are part of the framework. So the framework is built on top of itself. It handles authorization, authentication, file management. So all of these endpoints are related to that. These are the ones that are stock. So to retrieve a stock, it's telling me that I have to be authenticated, and I need to do that. You saw that I didn't write any single endpoint or anything like that. And then what I have to do is I had to get the token, which I think is going to be, it's in the terminal here, right, cool. So this is from a local, it says copy into the keyboard, but I don't trust it. Command tab, yeah, yes, okay. So I authenticate, Command V. I try it out, and I cannot retrieve. So I'm going to try to retrieve a stock from a product that doesn't exist, and I am just going to get a 404, but request, because the quantity is not, okay. So if I try to retrieve a stock, I'm going to get a 404 because the entity doesn't exist yet. I am going to receive some stock. So I get 13 of something. I execute. This worked. And if I try to run this against the same ID, you're going to say that I got a 200. And if I go to the read models, this thing gets hydrated directly with the 8. As you can see, all of the logic that I wrote was just a function mapping from here to here and 3 definitions, plus the events, 5 definitions. The thing is, the model that you saw before in the slides matches 1 to 1. So every element that you have in the model will match to one file in the code, to one class in the code. Every class in the code will match to one element in the model. 1 to 1. Nothing in the code is not in the model. Nothing in the model is not in the code. This makes changes really, really easy. Right. And also, just to sell some kind of magical hoodoo here, is that the stock read model, let's say that instead of showing the quantity, we just want to say bool has stock. No, this. Oh, thank you, AI. I mean, you're coming for my job, so might as well help me. And now restart this. I Command V. I restart this, and if I go now to the stock, you will see that has a stock is true because we know it had 8, I think. So if I retrieve 8 stock, there was enough stock. So let's see. Yeah, has a stock false. Did you see me do any database migration? That's the magic of this. So what it does is it just takes the signature of the read model, generates a hash based on all of the types, even nullability changes, annotations for indexes, things like that. Takes all of that, generates a hash, creates a table in the database, and hydrates the story from the present to the past. So you get all of that data there. And how do you do zero downtime? Instead of modifying a read model, you can create a copy of the read model with the new fields. And it can just start hydrating, and you can start consuming in the front end as it gets hydrated. Back to the demo, but to the slides. So the story is, remember the word slices that I mentioned before? These are the slices. So you have the command, the read models, the processors, and you have views that might be a bit more complex, built on top of read models that already exist. So you end up having these few iterations, and you end up with an equation system that you can solve. And this pretty much leads to fixed costs because the slices, my experience with that, our experience with that, sorry, is that if someone does 5 slices a week, you normally do 5 slices a week because it forces you to split the features like that. And because the streams have their own consistency boundary, you have to treat each one of your business capabilities like a microservice. So it forces you to follow CQRS. It forces you to decouple all of your business logic, which is a pain in the ass sometimes, but it pays down the line because normally development time of features remains constant as you progress through the project. So you end up with a mythical man-month. You can split work to the point that you can bake a pizza in half the time by using 2 ovens. Right? I know it sounds a little that's something that you will have to try for yourself, but I think that the climb is worth it. So a few takeaways. I didn't show it because we're rushing here, but traceability, the commands that I issued in this demo, they have my user sub already there. And I didn't have to configure any of that. It's already part of the framework. It also has correlation IDs, causation IDs. When something is a consequence of something else, it has the ID of origin, so you can trace back everything that has happened. And I have traceback. Sometimes when you do a demo and you prepare the test data and the test data is missing, I know who did it. He's alive, by the way. No database migrations, which is amazing. You don't lose data. If you change a read model, you remove a column, you can restore that column and have all of this data. No database migrations. You have a lot of incentives in place to do CQRS and high decoupling, which is absolutely fantastic. Seriously, no database migrations. That's one of the key things. And simplifies workflows at Sagas, which unfortunately don't have the time to do a full on that. But it makes every step just a projection, a task. You draw a diagram, and you convert to that. That's pretty much it. Thank you. Is there any question?
First of all, thanks for the talk. I like that there's 3 times no database migration. But that brings me to the question, this seems amazing for engineers because no database migrations. But BI lives and dies by having a database where you can read the state of the world and make inferences about your business. How does that work in a CQRS world?
So there is a database. The SQL database that you saw there is a projection. It's like a cache. The database is the event store. That's a real database. It's immutable, except when you truncate streams. So you can delete, but you can delete up to a point or delete completely stream, but you cannot edit and you cannot insert in the middle. So you have an event log of everything. And if you think about it, imagine that you have a warehouse app and you find all of a sudden that of one of your products, you have -5 stock. Okay? Then you go to the logs, you check all of the operations that have been performed, and according to the operations, you have 3 stock. Which one do you trust?
The one that I count myself in the warehouse because...
Yeah, okay, right. But if you have those options, normally you go to the logs to check what happened. The whole point of event sourcing is that because you can only update the read models based on the logs, it forces you to have correct logs, comprehensive logs, and the only thing that you do is you constantly exercise making sense of those logs. So this guarantees that in terms of business transactions, you have everything correctly logged. And it comes with its own challenges, but that's not one of them, because actually it's the other way around. If you have a problem, if you have something that doesn't make sense in a SQL database, you need to figure out how you got here. Well, if you lose the Microsoft SQL, the migration, it's going to be a tad slow to hydrate the projections from the whole history of the system, but you can do it. And it will show there. It has happened.
Yeah, just to clarify the question a bit further, you define the projections in code, which requires now an engineer. So if BI needs a new projection, now they need to come by with engineering, which is always a bottleneck for the business to grow. I've seen businesses excel mostly when non-engineers can query the data on their own without the help of an engineer. Yeah. So that seems a bit prohibitive if you require an engineer to make all your predictions all the time.
Yeah. You probably noticed in the expression on my side that I have had that question before. You know the concept of fat tables, no? Mm-hmm. You just make a projection with a fat table. You make one, and they can use it. A matter of fact, because the level of decoupling this has, because the object that I told you, the event model that you show there, is composable. So we normally create one event model per business capability, and we do .merge when instantiating. You can have only the event model for the data that you want, create a new API, spin it up only with that read model, with the FAT table. And you have a SQL database that has only the data, it gets up to date, and it doesn't affect the performance of the rest of the system.
Thank you.
Okay.
Done.
Wow,
Hands
thank
off.
you. One last thing. Thank you.